Have you ever wondered what the universe is made of? Now, most people would say it's made of stars and planets and galaxies, but that's just the stuff we can see. In reality, 95% of the universe is invisible. And when I say invisible, I don't mean like the northern lights, which are actually visible. But most people just choose to ignore them because they read too busy mindlessly scrolling through their phone while standing under a beautiful night sky. No, I mean truly invisible. Like the kind of invisible you can't see with your eyes or detect with any of our current scientific instruments. What I'm talking about is dark matter and dark energy, two of the most mysterious phenomena in the universe. Together, they account for 95% of everything, yet we know almost nothing about them. But if you want to learn more, well, then you've come to the right place. But before we get started, be sure to hit that like button. It really helps my channel out a lot. Now, have you ever noticed how much mass every single object in the universe seems to have? I mean, from the tiniest subatomic particle to the largest star, everything has some sort of mass. And physicists have been trying to figure out what this means for over a century now. Albert Einstein was the first to propose a solution, and he had a pretty radical idea. What if mass isn't a fundamental property of the universe? What if it's actually a type of energy that's just really hard to detect? This idea goes against everything we know about physics, because normally energy and mass seem to be completely unrelated. Like, look at this apple here. If I want to calculate its mass, I can just weigh it on a scale. And if I want to calculate its energy, I can just measure how fast it's moving. The faster it moves, the more energy it has. But Einstein proposed that these two properties are actually related by a mathematical equation. E equals mc squared, where E stands for energy, m stands for mass, and c is the speed of light. This means that anything with mass also has energy. And that energy is always flowing from objects with a high mass to objects with a low mass. This might sound confusing, so let me explain with an example. Imagine you have two stars, one big and one small. The big star has a lot of mass, so it also has a lot of energy. Because of Einstein's equation, the small star doesn't have as much mass, so it doesn't have as much energy. But because the big star has more energy, energy will flow from it to the small star until they reach equilibrium. At this point, both stars will have the same amount of energy, and therefore the same amount of mass. So according to Einstein, all the mass in the universe is really just energy that has been converted into a form that we can detect. But there's a problem with this idea. If that's true, then all the mass in the universe should be flowing together, collapsing in on itself due to gravity. But we don't see this happening, so something else must be preventing it. Enter dark matter. According to Einstein's theory, dark matter is a type of energy that has a negative mass. This means it would push everything away from it instead of pulling it in like normal matter. And that's exactly what we observe. There seems to be some kind of force pushing everything apart, and we call that dark energy. Now, you might be wondering, if dark energy is a type of mass, why doesn't it have a gravitational pull like normal matter? Well, that's because the further away an object is, the less gravitational pull it has. And dark energy is so far away, it's essentially zero. So, to summarize, dark matter is the negative energy that makes up 27% of the universe, and dark energy is the negative mass that makes up 68% of the universe. Together, they make up 95% of everything, yet we know almost nothing about them. The good news is that scientists are working on it. In fact, they've already detected dark matter. They haven't been able to detect dark energy yet, but they think it exists. And if you want to learn more about space, well, then you've come to the right place. Now I have a favor to ask. If you want my channel to keep growing, then please hit that like button. It really helps us out a lot. Thank you so much for watching. I'll see you next time.